In the early 1960s, you didn't have to watch any race to know the winner was a Ferrari. Ferrari literally decided the terms of every famous competition. Their cars were sophisticated, powered by V12 engines, and wrapped in bodies that looked like sculptures. They were the gold standard of mechanical engineering and corporate prestige. Against them stood the Shelby Cobra. On paper, the Cobra should have been the Ferrari killer. It followed a simple, effective formula: a lightweight British chassis paired with a reliable, high-torque Ford V8 engine. In short-distance sprint races or on tight technical tracks, the Cobra was nearly untouchable. It had a power-to-weight ratio that made the Ferraris look heavy and overcomplicated. However, when the Cobra arrived at the high-speed circuits of the European continent, places like Le Mans or Reims, the advantage disappeared. On the Mulsanne Straight, a nearly 4-mile stretch of public road where cars reached their absolute maximum velocity, the Ferraris would pull away. The Cobras would hit a wall at roughly 150 miles per hour. No matter how much more power Carroll Shelby's team squeezed out of the 289 cubic inch Ford engine, the top speed remained stagnant. The engineers first assumed this was a mechanical failure. They looked at gear ratios, they looked at heat management, but the problem was not under the hood. The Cobra was a victim of its own shape. At high speeds, the open cockpit Roadster acted like a parachute. It was physically pushing too much air. The car had reached an aerodynamic ceiling. In the 1960s, the prevailing wisdom was that to go faster, you needed a longer car with a more powerful engine. The Cobra had neither. It seemed that the American challenge to Ferrari had reached its natural limit. By 1963, the situation for Carroll Shelby was difficult. While Ford was already pouring resources into their own prototype program, the car that would eventually become the GT40, Shelby faced a different strategic hurdle. To win the prestigious Grand Touring class and defeat the Ferrari 250 GTO, Shelby had to follow strict FIA homologation rules. These regulations dictated that his race car must be based on an existing production chassis. Shelby was told to win the GT class, but he had to do it using the existing Cobra Roadster frame. This created a massive technical contradiction. To beat Ferrari at Le Mans, Shelby needed a car that was 30 miles per hour, faster than the current Cobra. Usually gaining 30 miles per hour at the top end requires doubling the horsepower, which the small Ford V8 could not do while being reliable for 24 hours. The team could not change the engine, and they could not change the frame. They were trapped by their own inventory and the rulebook. Enter Peter Brock. At the time, Brock was a young designer who had been the first employee at Shelby. He was not a classically trained aerodynamicist with a degree from a prestigious university. In fact, many of the veteran mechanics in the shop viewed him as a stylist rather than an engineer. But Brock had a different perspective on the problem. He realised that if they could not increase the push from the engine, they had to decrease the pull from the atmosphere. The decision was made to build a coupe body over the existing Roadster frame. But this was not a project backed by a massive research and development budget. It was a parts bin operation. Every dollar spent on a component was a dollar taken away from the racing budget. The strategy became one of radical optimization. Find the most efficient way to wrap the existing body in a shape that ignored the design trends of the day. When Peter Brock rolled out the first sketches of what would become the Daytona Coupe, the reaction from the shop was largely negative. The car looked wrong. At a time when Ferrari was building long, elegant, tapering tails that looked like teardrops, Brock's design was blunt and aggressive. It featured a roofline that stayed high and then dropped off almost vertically at the rear. The drivers were sceptical. Ken Miles, one of the most talented development drivers of the era, initially thought the design was a mistake. The automotive world believed that for air to flow smoothly off a car, the body needed to be long and pointed. Brock's design, known as a camback, defied this. Brock had based his design on obscure German research from the 1930s. The theory was that a car did not need a long tail to be aerodynamic. It just needed the air to think there was a tail there. By cutting the back of the car off abruptly, you could create a zone of low pressure that essentially tricked the air into behaving as if the car were much longer than it actually was. This was a counterintuitive approach. To the eye, it looked like half a car. To the air, it was the most efficient shape on the track. When they took the first prototype to the Riverside Raceway for testing in February of 1964, the tension was high. If Brock was wrong, Shelby had wasted months of time and a significant portion of his limited budget. But the data was undeniable. Without touching the engine, the car was suddenly hitting 183 miles per hour. The aerodynamic ceiling had been shattered not through brute force, but through a shape that the rest of the industry considered ugly and unfinished. If you don't want to miss out on anything cars, make sure to subscribe. While the shape of the car was revolutionary, the way it was built was almost primitive. This is where the business strategy of Shelby American diverged most sharply from the European philosophy. Ferrari built racing cars like watches. Every screw and bracket was a custom machine piece of art. Shelby could not afford that. The Daytona Coupe was a triumph of the $5 part. If you look closely at the interior and the hardware of the 6 Daytona Coupes ever built, the lack of prestige engineering is startling. The door hinges were simple, heavy-duty pieces you might find on a truck or a shed. The latches were basic industrial hardware. The switches on the dashboard were off-the-shelf toggle switches. Even the glass was a strategic compromise. While the team went to great lengths to adapt a massive glass windshield from a production Ford Galaxy by mounting it at a radical angle to fit the small chassis, the side windows were simple plexiglass. It was cheaper, lighter, and most importantly, easy to replace. This was a deliberate choice of reliability over elegance. In a 24-hour race, a custom-made Italian door handle that snaps off can end your race if the driver cannot get back into the car after a pit stop. A $5 steel hinge from a local hardware supplier, however, is nearly impossible to break. And if it does break, you can find a replacement in almost any town in Europe. The team built only 6 units. This was another calculated business decision. By keeping the production run extremely small and using standard parts, they bypassed the perfectionism trap. They didn't need the cars to be beautiful or consistent. They needed them to be functional and identical under the skin. This allowed for a hot swap mentality. If a part failed on car number 10, the mechanic knew exactly how to fix it, because it was the same $5 part found on car number 11. The Daytona Coupe was a specialised tool designed to perform one specific task for a very limited amount of time. In 1965, the Daytona Coupe achieved the impossible. It won the International Championship for GT manufacturers, ending Ferrari's decade-long streak of dominance. It was the first time an American manufacturer had ever taken the title. On the surface, the story of the Daytona Coupe is often told as the tale of American muscle overcoming European finesse. But that interpretation misses the actual engineering reality. Technically, the Shelby Cobra was already more powerful than its primary rival. The American V8 produced nearly 80 more horsepower than the Ferrari GTO's V12. The problem wasn't a lack of muscle, it was the inability to use it. The main idea that Peter Brock and the Shelby team proved was that engineering isn't always about adding more. It is about removing the obstacles that prevent you from using what you already have. The Daytona didn't win simply because it was stronger. It won because it finally possessed the aerodynamic efficiency to use its massive power advantage at high speeds. When we look back at the ugly, truncated tail and the $5 hardware store hinges, we are looking at a masterclass in trade-offs. The team understood that every bit of effort spent on the aesthetics of a door handle was effort not spent on the management of the air moving over the roof. The Daytona Coupe was faster than the Ferraris because it had a better understanding of the atmosphere around it, and it successfully used it to thrive and win races. Don't forget to subscribe to not miss anything cars and business.